matrix addition. How do we do it? Matrix addition. Suppose we had a matrix A, and we had a matrix B, and we want to add them together to get C. What's the first thing that has to be true about A and B? So they have to have the same number of rows and the same number of columns. So they have to be conformable for addition. Because addition takes place. Suppose that the typical element of A was A, ij, and the typical element of B, since they're conformable, was B, ij. So the ij element of big C is going to be constructed how? Right. So matrix addition is done element-wise, provided the two matrices are conformable. The commutative property in algebra. And what is the commutative property? Yeah. So A plus B is equal to B plus A. So does that apply to matrix addition? Yes. So there are some things in matrix algebra that work just the way they do in scalar algebra, namely the commutative property holds. What's the associative property? Right. So it's just how you prove things. So the associative law applies in matrix algebra just as it does in the scalar algebra. How do we do matrix multiplication?
Okay, well, we need conformal matrices.
So you need two conformable matrices, and
Right.
what's the sense in which they have to be conformable?
The inner dimension has to match. So if you're saying A dot B, then...
Okay, suppose that A is m by n,
Right.
and B is k by L.
When you want to multiply A times B,
I want to construct A times B to get C. And what has to be true?
N must equal K.
So then N has to be equal to K. And what's going to be the dimension of C?
M by L.
C is going to be M by L. So if you can do it in your head, what's the ij element of C?
That would be the inner product of the ith row from A and the jth column from B.
Perfect. Everybody heard? And yeah, perfect. So you just take the ith row out of A and the jth column out of B, construct the inner product, and you get the ijth element in C. Very good. What's the determinant of a matrix? We talked about this very briefly last week. Tell me again. The determinant of a matrix is a scalar valued representation of the matrix. So in geometry, it's either the area or the volume of the shape enclosed by the vectors of the matrix. So, true or false? The determinant of A equals the determinant of the transpose of A. Quiz show. Suppose I switched a pair of rows or a pair of columns. What would happen to the determinant of A? Suppose I take the first row of A and I switch it with the second row of A. Yeah, so then I switch the sign on the determinant of A. Or if I switch two columns, I switch the sign on the determinant. Suppose I multiply a row or a column by a scalar. What happens to the determinant by how much? Suppose I had a matrix A and I multiplied every term in the first row by 3. What would happen to the determinant of A? Yes. Sometimes my questions are rhetorical. That means by listening to the question, you know the answer. Suppose that I have a matrix A and I learn that two rows are linearly dependent. What happens to the determinant of A?
It would be 0.
It would be 0. Okay, so in order to get a non-zero determinant,